So in this video, so we are discussing about that. So ellipse shortcuts. So let me explain. So the shortcuts of ellipse. So first, what is meant by ellipse? We are discussing one by one, right? In this video, we are discussing about the ellipse. So ellipse. So ellipse is nothing but like this. This is the ellipse. So S is the focus, P is any point on the ellipse. This one is so fixed lines. So fixed lines, these are called directrix. Later on we are called as directrices, two directrix. So that is SP by, so that is perpendicular distance. SP by PM equals to E. So the less than 1. E is called the eccentricity. SP by PM equals to E, less than 1. It is called the eccentricity. There must be two directrices, two eccentricities, and these are called when. So we are discussing about, this is called that when A greater than B, major axis and minor axis, a vertical line perpendicular to that is called the lead. So this one is called length of lattice rectum. Once this is the focus. So okay, this one is one focus, this is another focus. So this one is lattice rectum. So this is vertices of ellipse. A and A dash are the vertices of ellipse. These are the equation of directrices. This is the axis of major axis. This is axis minor axis. This is about that. One more concept. So SP by SP plus S dash P. S is a point like this. SP plus S dash P equal to 2A. The locus of P is an ellipse, that is. So S comma S dash are the two fixed points. P is any point such that SP plus S dash P equal to 2A. That is called the ellipse. So let me discussing about the how many types of ellipse are there. How many types ellipse are there? We are discussing one by one. Right. There must be some columns like this. Type 1, type ellipse. So type ellipse, eccentricity E. Now equation of directrix. Equation of directrix. Equation of directrix. So length of lattice rectum. Now major axis length, and minor axis length. So here is now eccentricity, equation of directrix, equation of length of major axis, ends of lattice rectum. This is also very important. Ends of lattice rectum. So lattice rectum. These are what we are discussing about here. So first case is like this. So x square by a square plus y square by b square equals to 1. So a greater than b. There is a case. A greater than b. Eccentricity root of a square minus b square by a square. Equation of directrix x equal to plus or minus a by e. Length of lattice rectum 2b square by a. Major axis. So major axis means x-axis. X-axis is y equal to 0. Its equation is y equal to 0. X-axis. Its length is 2a. Now coming to that, length of minor axis, x equal to 0, y-axis, its length is 2b. So that is ends of lattice rectum, it is nothing but ae comma b square by a. So that is like this. This is the ellipse like this. Ends of lattice rectum, that is ae comma b square by a. And now one more, that is ae comma minus b square by a. So ae comma minus b square by a. This side also there correspondingly. Now if you take like this, x square by a square plus y square by b square equals to 1. So here is b greater than a. Here is b greater than a. Eccentricity taken as b square minus a square by, that is b square. Y is taken as plus or minus b by e. So that is 2a square by b. So this one is length of major axis. It is to be changing like this. This is the ellipse like this. This is called the major axis. That is Here is changing, right? That is x equal to 0, y-axis. There is major axis is 2b. Y equal interchange, so that is 2a. Here is these points. These points are taken like this. This is BE. So BE comma, so that is this one is a square by b. So BE comma minus a square by b. These are the ends of lattice rectum. So remember this. First, this chart you can solve the problems. Basically, the problems are solving easily if you know this table easily, right? So let me explain some more formulas in this one. Right. First, let me explain. Suppose one by one shortcuts. So why they are using in this one? So let me explain shortcuts one by one. Formulas also same. In this one, more formulas are there. So remember one by one. Suppose if you take it like this, so y equals to, suppose y equal to mx plus c. Y equal to mx plus c is a tangent to the ellipse. So condition is that is c square equal to a square m square plus b square. This is the condition for the tangent condition, right? So this is the tangent to the ellipse, right? This is the touches at the point minus a square m by. So the point of contact where it touches is, remember that. So remember that it touches this. So minus a square m by c comma b square by c, minus a square m by c, a square m by c, b square by c. This is the formula. Minus a square m by c comma b square by c. This is the formula using this point of contact. Point of contact taken as minus a square m by c comma b square by c. This is the tangent condition. This is the tangent condition. Now, suppose notation is very important. Notation is very important. That is coming to the second point like this. Suppose ellipse is like this. Ellipse is like this. From Px1, y1, suppose S11, that is S11 greater than 0, the chord lies outside the ellipse. So from this, two tangents are drawn. This one, from the two tangents are drawn, they touches the ellipse at A and B. Then AB is called the chord of contact. So from this one, two tangents are drawn. So PA slope, PA comma PB, slopes are that is M1 comma M2. Now, so M1 plus M2 equals to, suppose the formula 2x1 y1 by, so x1 square minus a square. This is the shortcut. So M1 comma M2 are the slopes of two tangents PA and PB. Then so the sum of the slopes M1 plus M2 is nothing but, so that is M1 plus M2 is nothing but 2x1 y1 by x1 square minus a square. Now, so product of the slopes M1 into M2 equals to y1 square minus b square by x1 square minus a square. From this, one more shortcut we know that. If this one, listen, suppose M1, M2 equals to minus 1. The two tangents are perpendicular. Minus 1, y1 square minus b square by x1 square minus a square. That is, if you find this one, x1 square plus y1 square equal to a square plus b square. So the locus of Px1 y1 is, it is nothing but x square plus y square equal to a square plus b square. This is called director circle. Remember that. What is this one? Called director circle. This is called the director. The locus of perpendicular tangents of an ellipse are said to be the director circle. So the equation is x square plus y square equal to a square plus b square. Suppose the angle between the tangents is theta. Now we taken as a shortcut formula. Tan theta equals to, there must be the easy to remember the formula. 2ab into root s11, 2ab into root s11 by x1 square plus y1 square minus of a square plus b square. So S11 already we know that is x1 square by a square plus y1 square by b square minus 1. Substitute there 2ab into root S11 by x1 square plus y1 square minus a square plus b square. This is the shortcut of the tangents. Two tangents are drawn. So that is, so slopes are m1 and m2. Generally they are asking, generally director circle they are asking. So m1 plus sum of the slopes 2x1 y1 by x1 square minus a square. Angle between them tan theta equals to 2ab into root s11 by, so this is the formula, x1 square plus y1 square minus a square plus b square. This is about the tangents. Suppose this is about the tangent. Suppose one more thing, that is once asking the question, suppose one more shortcut is there like this. Right. Suppose third shortcut is like this. So Lx plus my plus n equals to 0 is a tangent. Is a tangent to the ellipse. Tangent to the ellipse, then condition is a square L square plus b square m square equals to n square. This is the very important shortcut. So that is ellipse equation is same, x square by a square plus y square by b square equal to 1. So condition is a square L square plus b square m square equal to n. Suppose so this is the ellipse. So this is S is the focus. S dash is another focus. So B is the, this is, O is the origin, right? If BS makes an angle theta at minus, this is that. So this one angle makes an angle, OS makes an angle at, this one is angle theta, then cos theta is the eccentricity. This is one more shortcut. Suppose OS makes an angle with BS is theta, then cos theta is called the short. Suppose once again the question asking like this, angle BSO equal to 30 degrees, then E equal to formula cos 30 degrees root 3 by 2. This is the shortcut formula. We have to solve that. So this is the shortcut formula. We have to solve that. Similarly, there must be the, so last one is acetric angles. What are the acetric angles we are discussing? So what are the acetric angles? That's a very important shortcut formula we are having. What is meant by acetric angles? That we explain, and based on that some formulas are there. We will discuss about that formulas. What are the acetric angles? Acetric angles like this. So this is the ellipse. So this is A is called A cos theta comma B sin theta. So this is parametric form. So A is taken as A cos theta comma B sin theta. So theta lies between 0 to 2 pi. This is called acetric angle. So acetric angle lies between 0 to 2 pi. So this is, now suppose 2 points are given. This is B also given. So that is suppose two formulas. A is given as alpha sometimes. Alpha means A cos alpha, B sin alpha. So B is given as suppose, so beta in terms of beta, A cos beta comma now B cos sin beta. Then equation of AB chord. Equation of AB chord, it is nothing but, so that is x cos alpha plus beta by 2 plus y sin alpha plus beta by 2. So x cos alpha plus beta by 2, y sin alpha plus beta by 2 equals to cos alpha minus beta by 2. This is the equation of chord in acetric angles. That is the equation of chord in acetric angles. What is the equation? So equation of chord is x by A cos alpha plus beta by 2, y by B sin alpha plus beta by 2 equals to cos x by A cos alpha plus beta by 2, y by B sin alpha minus b sin alpha plus beta by 2 equal to cos alpha plus beta by 2. In this one more shortcut. If it is A, if it is focal chord, If it is focal chord, focal chord means passing through focus. Passing through focus. Focus is AE comma 0. Substitute there. So that is AE by A cos alpha plus beta by 2 equals to cos alpha minus beta by 2. From this one, A cancel. Cos alpha minus beta by 2 by cos alpha plus beta by 2 equals to E. From this one, we are having one more formula. Tan alpha by 2, tan beta by 2 equal to E minus 1 by E plus 1. This is the most useful formula. Here is, let me explain, that is the equation of chord AB. So that is A is given as alpha. So B is given as beta. X by A cos alpha plus beta by 2. Y by B sin alpha plus beta by 2. If it is the focal chord, condition is E equal to, sometimes this is asking, sometimes tan alpha by 2 into tan beta by 2 equals to E minus 1 by E plus 1. So these are the very important shortcuts while solving the problems. Now, so one more is like this. Suppose there must be, suppose what is the area, suppose asking in area's point of view. In area's point of view, one shortcut is there, remembering that. Suppose ellipse equation is given. Suppose in ellipse, this is x square by a square plus y square by b square equals to 1 area. Already we know that. Already area is pi AB. So the maximum area of rectangle inscribed in, so ellipse, that is nothing but, in this is the ellipse, so that is rectangle is to be inscribed, its area is, so that is very important, 2AB. So with sides A root 2 comma B root 2. So this is the very important shortcut we are having like this. So area pi AB, area of ellipse, already we know that. The maximum area of rectangle inscribed in ellipse is 2AB with sides A root 2 this side. This side is B root 2. A root 2 comma B root 2. So this is way of remembering this one. Now let me explain one more concept. Suppose common tangent concept. What is the concept of common tangent? Let me explain the common tangent concept. So common tangent concept. In this one, what is meant by common tangent? Suppose given like this. Suppose x square by a square plus y square by b square equal to 1 and x square plus y square equal to r square, they have a common tangent. What is the slope of that common tangent? He is asking so many times in the examination. X square plus y square equal to r square is the circle. X square by a square plus y square by b square equal to 1. Having common tangent. So that is slope of tangent is root of, it is nothing but root of r square minus b square by a square minus r square. This shortcut is very important. So this is the shortcut so the common tangents, right? So what are the common tangent of this one? This is very important. Next one is auxiliary circle. That is also asking what is the equation of auxiliary circle for ellipse. So first case, x square by a square plus y square by b square equals to 1. A greater than b, auxiliary circle. It is nothing but, so x square plus y square equal to a square. If b greater than a, so auxiliary circle is, so that is x square plus y square equal to b square. So these are the auxiliary circle, that is very important. So the auxiliary circle definition is like this. So the locus of focus on any tangent, the locus of put off from the focus, the locus of put off perpendicular onto the tangent is said to be the auxiliary circle. So that is the equation of auxiliary circle. A greater than B, x square plus y square equal to a square. B greater than A, x square plus y square equal to B square. So one more very important shortcut, sometimes asking in the examination, that is normal. If Lx plus My plus n equal to 0 is a given line, Lx plus My plus n equal to is a given line, becomes normal to the ellipse x square by a square plus y square by b square equals to 1, then condition is, so remember that condition, a square by l square plus b square by m square equal to, that is a square minus b square whole square by n square. So last shortcut, so I will write on the board, remember that. So Lx plus My, so Lx plus My plus n equal to 0 is a normal to the ellipse. Condition is a square by l square plus b square by m square equal to a square minus b square whole square by n square. This is a very important shortcut for solving the problems. Remember that. So Lx plus My plus n equal to 0 is a normal to the ellipse, that is a square by l square, b square by m square equal to a square minus b square by whole square equal to n square. So here also pole, we know that pole conditions. So suppose pole, the pole of, so pole of Px1 y1 is S1 equals to 0. That is very important. S1 already know that xx1 by a square plus yy1 by b square minus 1 equals to 0. So that is, this is very important formulas, right? That is, so midpoint of the chord given, like this is the ellipse. So chord midpoint is given. Px1 y1 is the midpoint. So Px1 its equation is S1 equal to S11. Already we know that S1 we know that, S11 we know that. So that is the equation of S1 equal to S11. Now let me explain. So now normals, right? All of you know that. Suppose parametric form P equal to, that is A cos theta comma B sin theta. So tangent equation is Ax by, that is x by A cos theta plus y by B sin theta minus 1 equal to 0. So second one, normal equation is Ax by cos theta minus By by sin theta equals to A square minus B square. Please concentrate all these shortcuts, then go for solving the problems. You can get it easily. So if you want to get the problems, first you go through the theory part and shortcut forms. Wherever the shortcuts are there, you have to find out. Then only we can solve the problems easily. So in this video, so these are the shortcuts about the ellipse and formulas. So better to know all the concepts and shortcuts, then you go for the problems. Within very short period we will get the answer. So thank you for listening my video.